Hello, students. Today we will discuss the difference between the relative gravitational potential energy and the absolute gravitational potential energy. Let us first talk about the relative gravitational potential energy. For example, there is a body which is lying on the surface of the earth. In this case, we will say that its potential energy is zero because according to the formula mgh, as the height of the body from the surface of the earth is zero, therefore we will say that its potential energy is zero. And at a certain height h from the surface of the earth, we will say that its potential energy is mgh. Which this potential energy we will find this formula work is equal to which is F represent our applied force. Okay, this FD cos theta is a dot product or scalar product between the applied force and the displacement which is being covered by the body. As it is clear that force and displacement both are in the same direction, therefore when two vectors are in the same direction, the angle between these two vectors is zero. In this case, cos 0 comes out 1, and this applied force will be equal to the weight of the body, which is mg, and if this displacement which is covered by the body is h. Therefore our final formula is mgh. But we must know that our applied force must be equal to the weight of the body, not less, not greater. In this case, we can see that our applied force is upward and the weight is acting downward. So the resultant force on the body becomes zero. If we apply the Newton's second law of motion, F is equal to ma. F, you know that the Newton's second law of motion is the resultant force. Our resultant force becomes Fa minus W. W is the weight. Okay, now the net force on the body is moving is zero. Therefore acceleration is zero. Acceleration is zero means the body is moved with the constant velocity through this vertical height h. Because we want that our work should convert into the potential energy of the body, and our work which is being done by the force Fa should not increase the kinetic energy of the body. As you know that the kinetic energy of the body is equal to half mv square. If v increases, the velocity or speed of the body increases, it means its kinetic energy also increases. Therefore, to keep it constant, speed of the body constant, to keep it constant, the acceleration must be equal to zero. Therefore, it is very necessary condition that the in moving the body upward, our applied force must be equal to the weight of the body. So the net force on the body is zero. Now we must know that potential energy on the surface of the earth is actually not equal to zero. Why? Because we know that when there is a attractive forces between different things, for example, that force of attraction between the earth and the mass of a certain body which is lying on the surface of, there is a force of attraction. It means that this body is now under the influence of the earth. Similarly, electron revolving around the nucleus is under the influence of the nucleus, and the two bodies which are attached, are a body of mass m which is attached to the spring also will also have some potential energy. But when a body which is lying on the surface of the earth, it is the force of earth is still acting on the body. The body is still under the influence of the earth, or the force of gravity is not zero. Therefore, how we can say that the potential energy is zero? Actually, it is wrong. That's why it is wrong. But so actually what is happening? We are finding out the potential energy of a body relative to the ground. Therefore, we take the potential energy of any body on the surface of the earth is equal to zero. Now I show it to you how it happens. Now I will show you that when there is a force of attraction between two bodies, the body will have the negative potential energy, but the potential energy of one body with respect to other will be the positive. For example, a body is lying on the surface of earth and its potential energy is minus 50 joules. It is correct because the body is in the force attractive field. Now when we lift the body through this height h, in lifting it, its potential, we have to do some work. This work will stored in the body as increasing the potential energy of the body. It means it will become less negative. You know that uh, uh, when a value becomes less negative, minus 10 is greater than minus 50. Therefore, let us take here is the body is here the potential energy is minus 10 joules. Now let us find out how much change energy has occurred in moving the body from this to this place. Now it is equal to the change in potential energy, which is a higher value minus a smaller value. It comes out the change in potential energy is 40 joules. Now consider the same case which you usually take. For example, we take it is potential energy is 0, which we normally consider in our calculation. Okay, it means this change is now 40 joules. It means we have to add 0 plus 40 uh, uh, at this place. For example, if I take the potential energy on the surface of the earth 0, then at this point I have to take the potential energy of the body is equal to 40 joules, because 0 plus 40 is equal to 40. Okay, now when in this case, when I calculate the change in potential energy, because I taking the potential energy at the surface of the 0, it makes no difference and our result is the same as in the previous case. Okay, when we are taking the negative potential energy in the earth gravitation, it means if it is in the earth gravitational field, it means if it is a body is lifted from the surface of the earth to a very high distance, to a very large distance from the center of the earth, so that where the force of gravity becomes 0, it means the value of g becomes 0. At this point the potential energy of the body will be equal to 0. Why it is potential energy at this point is 0? Because now the body is no more in the influence of the earth, or there is no force of attraction on the body of the earth. Now let us talk about the absolute potential energy. The gravitational potential or absolute gravitational potential is the work done in moving a body of unit mass from infinity, where the earth gravitational field becomes 0, to a point. Let us see how it happens. Okay, let us consider a body which is lying at a height h, at a very large distance from the center of the earth, where the earth gravitational field becomes 0, or the value of small g becomes 0, and we say that this body has infinitely large distance from the center of the earth. Okay, it is a point A. Now we want to this body. Here its potential energy is 0. Now it is very correct to say that its potential energy at point A is 0, because the value of g is 0. Now this body is moved or brought from point A to point B. In bringing the body from point A to point B, we have to do some work on it. This work will be negative, because we have to apply the force Fa in the upward direction, and the body which is covering the displacement in the downward direction. This applied force must be equal to the weight of the body. Why it is weight of the body? Because the weight is already acting in the downward direction. To keep the velocity constant, as we have considered in previous case, this applied force and weight must be equal to the force becomes 0 and the velocity comes out 0. And we want only convert our applied work into the into increase or into convert the potential energy of the body, and we don't want to our work should increase the kinetic energy of the body, or to keep the velocity of the body constant. Okay, so our applied force is still in the upward direction, but we moving the body from A to B in the downward direction. Okay, this for in this in bringing this body from A to B, this work will be stored in the body as a negative potential energy of the body, not positive, because we are doing the negative work on it. When we do the positive work on the body in moving a body from, for example, A to B, it will be stored in the body as a positive potential energy of the body. But when we are doing the negative work on the body in moving a body from A to B, it will be stored in the body as a negative potential energy of the body. In other words, we say that potential energy of the body was zero. Actually, when we are lowering the body, we are decreasing the potential energy of the body. Now, we know that when we decrease anything less than zero or lower than zero, it will be definitely negative. So, the potential energy of the body at point B will be the negative. In other words, we can understand in this way. Okay, in this way. Okay, now what is the absolute potential, gravitational potential, or simply gravitational potential? Actually, it is nothing but it is the work done per unit mass. Okay, the work done per unit mass means that you will divide the potential energy by m. It will come out the potential energy per unit mass, or simply the gravitational potential, and it's the formula which is in your syllabus. Okay, thanks.